Hello, good morning for you. Today we're going to do graphing quadratics, which has a direct connection to completing the square. But again, this is, like I said, all we're doing this entire week. So write this down, pause when necessary because I'm going to fly through this right now. But yeah, graphing quadratics, which is the shape of a parabola. Just some basic rules you got to know when doing this. First things first, look at the equation, guys. If it's y equals x squared, if that's a positive x squared, you know this faces right side up. If this is y equals negative x squared, that negative sign, it's upside down. I can't tell you how many times I've been doing this and how many times I've stressed. Just look and think, is this right side up or upside down? And that will help eliminate some patterns of thinking to make sure you don't make a mistake. First things first. Number two, find the vertex by completing the square. We've been doing that, so I'm not going to waste any time. Find the zeros, which are the solutions. Most times there are two. Sometimes there's going to be one, and other times there's going to be none. And that's what we're going to be looking at today, tomorrow, and most likely Friday. Last but not least, you want to try to find 5 points in order to establish a good shape of your graph. Now, 3 is okay. I'm meticulous because as you move through this concept, having 5 will sometimes just embed this concept a little deeper. So, those are the 5 basic rules. Now let's do some math. All right. So, all right. First things first. Let's start easy. Okay. I got y equals 3x squared. Now you're going to see some similarities between this and absolute graph, absolute value function graphing, and I'll show you what I mean by that in 1 second. In this case, guys, there is no need to complete the square because I already know my vertex, okay? Because when x is 0, y is 0. This happens to be a one solution situation, and as you practice this, these are generally the easiest. So, as we learned in the past with absolute value function graphing, just use that 0 as the benchmark and then go 2 above, 2 below, okay? And you'll see how the shape of this graph is similar to a shape of an absolute value. So -2, -1, 0, 1, and 2. In these situations where all you have is the ax squared is when you can ignore completing the square, ignore a lot of stuff because you'll see as you go through this how this will make sense. When x is -2, I get 4. 4 times 3 is 12. X is -1. -1 squared is 1 times 3 is 3. When x is 0, y is 0. When x is 1, y is 3. When x is 2, y is 12. Hence that symmetry on the point testers. Now, when you're graphing this, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, -1, 3, 0. There's our vertex, the minimum point. And then we got right about there and right about there. This is a U-shaped graph, not a V, but again, a lot of similarities between this and an absolute value function. Graphing. Now, again, this is the quick and easy form of how to do a question like this, which you'll see in today's work. Let's do another one that is kind of like this, but I graphed my 5 points, I knew it was right side up because it was positive, and I go from there. Now let's say I got another one, such as y equals -half x squared, okay? Well, it's negative, so that means it's upside down. Do not make that little mistake. And because all I have is the ax squared, I can use my quick and easy. Now, I'm going to do something different. I already know that 0 is my vertex, my bottommost point, because it's not going to go below that based on the situation. But instead of going -2, -1, 0, 1, 2, because this is -half, I'm going to just choose even increments. So I'm going to do -4, -2, 0, 2, 4, because I know how particular some of you are with finding the exact point. So in this case, being mindful that you can do this. You'd also be right if you chose -2, -1, 0, 1, 2. It doesn't make a difference, but I'm just showing you a different way to do this. Negative 4 squared is 16. 16 times negative half is negative 8. Negative 2 squared is 4. 4 times negative half is negative 2. X is 0. Y is 0. 2 squared is 4. And we see how this is symmetrical on our point testing table. So as I graph this, okay, and I can make my graph I can draw it according to make it fit what I know I'm trying to fit. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Boom, there we go. It's good enough. We know this is good enough. And negative 2, 2, 0, and my symmetrical. And try to make it a U-shaped graph as best you can. Okay, upside down. Now these next two examples I'm going to do for you are going to increase in difficulty. And I'm going to show you two ways to do them. Okay, so here we go. What just happened? So let's do this one. Y equals x squared minus 10x plus 16. So I'm going to do a couple of things because I got a big mess of a thing here, but I know that I've always stressed to you guys, when you're able to factor something like this, please do, because it makes it much easier. Because we're going to need 5 points, and I want you guys to try to find those zeros always. And in this case, what the heck is going on? Sorry, guys. So, first things first, before I do completing the square and find the vertex, I can quickly and easily see that this, in fact, factors into x minus 8 and x minus 2. Because I know what multiplies to positive 16 also adds to negative 10. X times x is x squared, negative 2x and minus 8x makes a negative 10x, and negative 8 times negative 2 is positive 16. So right off the bat, I quickly and easily, efficiently found that when x is 8, so one solution is going to be 8, 0, another solution is going to be 2, 0. Those are my two solutions, or my two zeros. Now I'm going to show you another way to actually get those exact same answers if you don't see it the way that I saw it. So let's do completing the square now. So now I'm going to do what I did yesterday. So I got x squared minus 10x, parentheses, remember, plus something, and then this is plus 16. Now, half of negative 10 is negative 5. Negative 5 squared is 25. I brought a 25 into this question that wasn't there originally. I take it out, put it right there, okay? So now I got x minus 5 squared. 16 minus 25 is negative 9, which equals 0. I now know my vertex is at 5 comma negative 9. So now I got 3 points, okay? And as I go further, I'm going to, now here's the other way. If I didn't see it like this that quickly, which is totally fine, I could just go straight from completing the square to find my solutions as well. You could always do this if you want. So let's solve this, and I'll erase this in just a minute to get a clean slate. I'm going to add 9, so now this says x minus 5 squared equals 9. Square root both sides. Remember, this is me plus or minus when you get this answer. X minus 5 equals plus or minus 3. Okay? Because remember, 3 squared is 9, just as negative 3 squared is also 9. So now let's find our solutions. I add 5 to both sides. So I got x equals 3 plus 5. And I also got x equals negative 3 plus 5. So x equals 8 and x equals 2. Hence, both of my solutions right there. Another way to do this if you'd like to do it that way. I always urge you to find the solutions of your graph. That's the whole point of graphing, to visually see those x-intercepts or those solutions, those zeros. Now, I got these points, okay? What am I going to do? I'm going to graph this. Now, I got 3 points, and this is good enough in this case because there's no need to go the extra mile, but if you want to, I'll show you something you can do. All right, so now I got this like this, and I got this like this. I'm going to graph my vertex first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make my life easier. Now I'm going to come over here and continue 8, 6, 7, 8. There's 1 0, and there's my other 0. Now, I have enough information here to graph this. Okay? So there's ultimately no need to graph 5 points, but if you want to be meticulous, and you can do that, I'm just going to pick a point in between here and try to solve. So I'm going to pick, just to make this easy, 3. Okay? If x is equal to 3, I can come up here and I use this equation, just point test. Alright, use mental math for this. Well, 3 squared is 9. 9 minus 30 is negative 21. And negative 21 plus 16 is negative 5. So when x is 3, y is negative 1, 2, 3, 4, 5. Look at that. Almost spot on. And then we also know symmetrical has to be right across the way from that, and that is almost perfectly graphed. But nonetheless, that's how you can do it. Another way to do 5 points. Not a necessity, but I'm urging you to do that. My last one. Let's do this one now. Now it gets a little trickier. Okay. So all right. So y equals negative 2x squared minus 36x minus 154. Notice how I haven't made a single mistake yet today because I didn't really feel the need to make a mistake on purpose like I have in the past because, I don't need to. Okay, let's do this. Now, I don't want to go through the hassle of trying to figure out my solutions first because this is kind of complex. I'm just going to use completing the square to find my vertex and my solutions. So let's do that. Now, here we go. I divide out. First off, is this facing right side up or upside down? Ask yourself. And I know this is facing upside down because this is negative no matter what. So I'm going to divide this out of just these first 2 terms. And this is going to be positive 18x. Half of 18 is 9. 9 squared is 81. Okay, I got a negative 154 right here. Now, remember to do this times this. Okay, negative 2 times 81 is a negative 162. I brought in a negative 162 that wasn't there originally. I must take it out. Positive 162 equals 0. Okay. Now let's factor it down. So this is negative 2, x plus 9, negative 154 plus 162 is positive 8 equals 0. So my first order of business, I got my vertex to be negative 9, positive 8. Please always organize your thinking, separate all your points so you're not making this a hot mess. Keep it easy. Now, let's solve for the solutions of this graph. Okay? So now just carry this out, divide by 8. This now says negative 2 times this is squared plus 9. Haha, you thought I'd make a mistake. That's not happening today. I told you. From day 1, from the second one, I was no mistakes. Divide by negative 2. So now this says, sorry, I'm running out of room. I'll put this over here. So now this says x plus 9 squared equals, do not forget to divide by this negative or else you're going to get a hot mess. This is going to equal 4 square root both sides. Remember, this is plus or minus, whatever you get here. So now this is x plus 9 equals plus or minus 2. So x equals, remember to subtract 9, negative 9 plus 2, and x equals negative 9 minus 2. So x equals negative 7, and x equals negative 11. So I got 2 more points. I got negative 7, 0. There's one solution, and I got my other solution at negative 11, 0. Okay? So let's go ahead and graph this. Okay? Got all that work. Pause when necessary so you can copy all this down. God, this is so much nicer than having to wait for those that don't listen in class to actually get something done in an efficient period of time, because you can just pause whenever you want. I'm sure some of you are muting me because you probably prefer that method. I'm going to do my vertex first. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, you guys have graph paper, so it should be much easier than doing it this way. Negative 9, 10, 11. There's one solution. Negative 9. What's up? I'm in the middle of teaching. You gotta wait 1 second. Alright, 1 second, sweetie. 1 second. 1, 2, 3, 4, 5, 6, 7. So, again, it's not fully necessary. Great job. 1 second, okay? Bye, sweetie. Alright. So it's not necessary to find another point, guys, because, I mean, and again, we can, and I'll show you, there's this, there's this. Only, if you want to find another point, only find a point that's in between these, so just do negative 10 if you want. And remember, you guys, and this is another way to use, just, remember, before we had the equation, withered down to negative 2x, plus 9 squared, and this was plus 8, okay, equals y. Another way, just basic substitution, let's just use negative 10 for instance, okay? Negative 10 plus 9 is negative 1, negative 1 squared is 1, 1 times negative 2 is negative 2, negative 2 plus 8 is 6. So negative 10, so 1, 2, 3, 4, 5, 6. Spot on, and then this is symmetrical, so this will be right here as well, again. So that's that. Alright guys, this is all you're doing today, so I'm sure there's going to be some questions. Please, all of you come and see me during the Zoom conference between 12:30 and 1:30, and I will answer all of your questions. Well, most of your questions. See you guys soon.